Welcome. In this session on natural deduction, we'll see how we can introduce a universal quantifier. This method is called universal introduction. Let's recall from propositional logic. Let's recall this. We had a rule that was conjunction introduction. And what this said was if two assertions are individually true, then combined they are true. And the rule that we had was that if we had a formula on a line and the same or different formula on another line, that we could conclude that the conjunction of those formulas is true, and the rule was conjunction introduction. Now we can think about an infinite number of assertions all being true at the same time. And when we assert that a universally quantified formula is true, that's what we're saying, is that for an infinite number of things, that formula still holds. So what we want to do is say if a statement about any in general is true, then it's true about all of them. So our rule is, this is universal introduction. And it has a special condition, and that is for a, we'll call it a fresh variable. And let's just use the symbol z for now. And we'll say where z is free for x in a formula that we're looking at, then if we have, our rule is, this is an assumption box, and what we have is we have the fresh variable here, and then we have a line of deduction, so it's 0 or more lines, and then we have a formula in which this fresh variable is free for x. If we have that construct, then we can deduce that this is true for all x with that formula, and this is our universal introduction. And by the way, this x here doesn't have to be the x that we're substituting in. This is a common mistake that students make, especially on tests, by the way, is that they'll put a y here because y was the quantifier they want. The convention is simply, we're going to call that the for all x. Now let's go through these pieces because this can be a little complicated. When we say that this variable is fresh, what we mean is that this variable is not mentioned in any previous line of the proof. That's what we mean by fresh. So you can't have mentioned this variable anywhere else. What we're doing is, let's think about what these assumption boxes are actually. What we're doing is say, for the purpose of argument, suppose that we think about this variable. And that's sort of what this assumption box is doing. It's saying, well, suppose for the purposes of doing a deduction, we introduce a variable. And if we can then arrive at a conclusion that mentions that variable and we have this free for condition, then if it's true for any fresh, or you can think of any made up, any temporarily assumed variable, then it's true for everything. This is probably best understood with a simple example. So let's take the sequent of the previous session and let's modify it slightly. Let's suppose that what we're asserting is everything, if something in general has the property P, then it has the property Q. And let's also suppose that everything that we're looking at has the property P, then we want to deduce that everything that we're looking at has the property Q. Now, in a previous session, instead of this for all x, we asserted that one object A had that property, and then we concluded that one object Q had that property. Now what we're doing is we're generalizing it along these lines, right? So what we're doing is we're saying if it's true for everything, and this material implication is true for everything, then that has to be true for everything. Let's see how this works. So we begin our proof by writing our premises. So for all x, if x is P, then x is Q. So that's a premise. And we also have, we're asserting that everything in our universe is P, so that's a premise. And we want to conclude that everything is Q. Well, what kind of reasoning is this anyway? Is this forward reasoning? Some people might think of it that way. I'd rather think of this as being backward reasoning. So let's note that as the strategy is backward reasoning. And that's a big matter because it's very easy in proofs for us to start introducing these assumption boxes without understanding where we're headed. It's a lot easier if we say that's how we got there. So here we could simply start introducing, for example, A, we could assert that if everything is P, then some particular A is P, but that doesn't seem like it's going to get us anywhere. Let's try opening up an assumption box. And what we do is, our discipline is we write the assumption box, we write the reason for the assumption box. So in this case, this is for all x introduction. And then we write the top line here. And in some texts, you'll see that they put an assumption, and in some they don't. We'll just leave the assumption out. And the reason is that it's going to make a certain rule in a subsequent session a little bit clearer if we don't put the assumption. So we'll fill out the top line, then we fill out the bottom line. Oh, so what's the bottom line? Well, the bottom line is we take the formula, our goal formula, and we substitute the fresh variable in for it, provided that fresh variable is free for, in this case, x. So here, we're quantifying over x, so we have to have something that's free for x. Is this variable free for x? Yes. Is this variable fresh in the sense it hasn't been mentioned elsewhere in the proof? Yes. So that means that this is a good choice. So I now take the formula that is being quantified, and I then substitute this fresh variable in. And I now ask myself, what could I do next? And it doesn't seem immediately that backward reasoning is going to take us very far. Oh, we could put a number 3 there. So what could we do? Well, we could try some forward reasoning, right? So let's try, for example, let's take this and let's use our universal elimination rule of the previous session and apply it. So if I apply it, I take this variable and I substitute in, provided that this variable is free for the quantified variable. Is that true? Well, yes, the quantified variable is x. If I put a z into those places, it doesn't become bound, so that's a good choice. So I can now take this quantified formula and substitute z into it. So that would be P of z, material implies Q of z, and this would be universal elimination based on line 1. Likewise, I could take this and I could substitute. Now, can I do that? Well, let's check this. Is z free for x in this formula? Yes. So that means I can. But am I allowed to substitute the same variable here as I did here? And the answer is yes. And we can reason this out. If we think about the semantics, about the meaning, if it's true for everything, then it's true no matter what fresh variable I pick. And this, if it's true for everything, it's true no matter what fresh variable I pick. So I can pick the same fresh variable. And that means that I could say this new variable has property p, and that comes from universal elimination, and that's line 2. Now I can just use ordinary propositional reasoning because I have the antecedent, I have the material implication, I can deduce the consequent. So I can justify, so that would be line 4, that would be line 5, and now line 6 I can justify as implication elimination based on our convention is line 5 followed by line 4. I've reached the bottom of the assumption box. I've filled in the entire assumption box. That means that I can now say that the next line has been justified logically, and that is for all x introduction, and that is working on lines 3 to 6. So I note 3 to 6, and I can assign that a number. And so we've completed our first proof that is using 2 of these quantification rules.